Okay, so finally here's section 4.8, part 3. This is the last little bit of video. I decided to break the video up into smaller chunks so it's not quite so long. Okay, our last little bit is talking about even and odd functions. Okay, just like a number is even or odd, a function can be even or odd. Or a function could be neither. That is an option. Unlike numbers, well, I guess there are some numbers that are neither either or odd, like the number 1/2 isn't even or odd. Okay, but a function can be neither as well. Okay, but an even function, what makes a function even? A function f of x is even if when I put a negative inside the function instead of a positive x, it doesn't change what I get out. Basically what this means is if I have a function and I put in a 2 and I get out a 4. When I put in a negative 2, I also get out a 4. Okay, that is an even function. So for example, here I have a function. Let's say I put in a 0, I get out a 0. When I put in a 1, I get out a negative 1. When I put in a negative 1, I get out a negative 1. When I put in a 2, I get out a negative 2. When I put in, positive 2, I get out a negative 2. When I put in a negative 2, I get out a negative 2. Okay. When I put in a 3, get out a 0. Put in a negative 3, get out a 0. Okay. So basically, what an even function will do is regardless of whether I put in a positive or put in a negative, I'll get out the same thing. Okay, so it has, and when that happens, what ends up happening is I end up having this nice symmetry. Even functions are symmetric about the x-axis. Sorry, y-axis, y-axis, y-axis. It flips it over the y-axis. Okay, so and again, an even function. Okay, so let's say I had a function f of x, blah, blah, blah. I don't know what it is, but I know it's even. If I know it's even, if I put in a, let's say I put in a 5 and I get out an 8. When you put in a negative 5, guess what you'll also get out? An 8. When I put, let's say when I put in a 15, I get out a negative 2. When I put in a negative 15, I also get out a negative 2. So regardless of whether I put in the positive or negative, these guys match. They're the exact same thing. Okay? It doesn't matter. Whether I put in a positive 5 or a negative 5, I'm going to get out the same output. Put in a 15 or negative 15, I'm going to get out the same output. Okay? Whereas an odd function is when I put in a negative x, I get out a negative f of x. Meaning when I change the sign of my input, it changes the sign of my output. Let's say I put in a 3 and get out a 5 in some function. When I put in a negative 3, I'm going to get out a negative 5. Okay, so a odd function, let's say it goes to the point 0, 0. Let's say when I put in a 1, I get out a 2. When I put in a negative 1, I'm going to get out a negative 2. Okay. Let's say when I put in a 3, I get out a negative 1. Well, when I put in a negative 3, I'd get out a positive 1. Okay. So it kind of, here's an example of an odd function. It would go like this. Okay. So when I put in, if I change the sign of what I put in, it changes the sign of what comes out. Okay, so basically what it means is, let's talk about symmetry first. We'll get to that. This is then symmetric about the origin. It actually does a bit of a spinny thing about the origin. It spins it around 180. It does a 180-degree spin. So if I take this and spin it around 180, if I take this guy and spin it 180, I get the exact same thing. Okay, so you get that 180 spin there. Okay, so again, if I had a function, let's go f of x equals dot, 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 dot. I don't know what the function is, but I know it's odd. Then I know, let's say when I put in a, let's say a negative 3, let's say I get out a 7. Well, if I put in a 3, I'd get out a negative 7. It changes the sign. Okay, so basically in short term what it means is if I change the sign of the input, For an even function, if I change the sign of the input, I put input. If I change the sign of the input, doesn't matter, output doesn't change. I still get the exact same thing. So meaning if I put a 5 in or a -5, doesn't matter, when I change that sign, I'm still going to get the exact same output. It doesn't change. Okay, an odd function, if I change the sign of the input, S-I-G, I'm having a hard time writing today, guys. If I change the sign of my input, it causes me to change the sign. It changes the sign of the output. Okay, so now an easy way of telling my test, to test for whether something is even or odd, is to put in an f of -x and see what happens. Does it change the sign of everything? Does it not change anything at all? Okay. Does it change the sign of just one piece? If it does change the sign of just one piece, then it's neither. Okay, so let's go ahead and let's look here. So here I have three functions. I want to determine whether the functions are even, odd, or neither. So to do that, I'm going to put a -x into my function. So we're going to go f of -x. So what that means is I want to come in, I want to replace these two x's, that one and that one, with a -x. Okay. So instead of having x to the third, I'm going to have a -x to the third, minus 7 times -x. So I replace this and this with a -x. And now we simplify. -x to the third, -x times -x times -x. Negative times negative times negative is negative, so it's going to give me a -x to the third. -7 times -x gives me a positive 7x. Now I compare the two. I compare the original to the new. Did it not change anything? Or did it change everything? The sign. Change the sign. So let's see. This is x to the third. This is now -x to the third. It changes the sign of that. This is -7x. This is positive 7x. It changed the sign of both of these. This one went from positive to negative. This one went from negative to positive. So that tells me it's odd, because it changed the sign of the output, my function. Okay. All right, let's go and let's look at another one. So here, this g of x. So to determine whether even or odd, we're going to go g of -x. So that tells me, again, I'm going to replace these x's, that one and that one, with a -x. So instead of x to the fourth, I'm going to have a -x to the fourth plus a -x to the second minus 1. Okay, now I simplify. -x to the fourth, -x times -x times -x. Negative times negative times negative times negative, that's positive. X times x times x times x, positive x to the fourth. -x times -x, that's just two of these. Negative times negative is positive, x times x is x to the second. And then we still have our minus 1. Okay, so again, we look at our original, we look at our new. Did anything change? X to the fourth, still the same. X squared, still the same. Nothing changed. When I put that -x in, it didn't change anything. Nothing changed, so that tells me it's even. Okay. All right, now let's do this last one, h to the -x. So again, we're going to replace this x with a -x. So that's -x. Negative times negative times negative is negative x to the third plus 2. Compare the original to the new. This is positive x to the third. This is negative x to the third. That changed, but this is positive 2. That's positive 2. That didn't change. The first one did. The second one didn't. It didn't change everything. And nothing, and it's not all the same, so it's not odd, because both of them didn't change. One of them changed, so it's not even, so that tells me this one is neither. Okay, all right, now get started on some practice.